Hey folks, this is Williams. Today's topic is domain. We are talking about domain and set notation in this video. Make sure that you have the notes pulled up on Google Classroom on a separate tab as we're doing this. So in Algebra 2, we did domain, and it looks something like this. We are adding a little bit to the way that we write it. We're writing it like this. This part at the beginning is new. It is pronounced X such that X is an element of the reals. All that means is that X can be anything between -3 and 5, including -3. It's not just integers. There's a separate symbol for integers, so things without fractions and decimals. So this is pronounced X such that X is an element of the reals. If you don't know what that means, I'm not that concerned with it as long as you're writing it. This is not pronounced X bar XER, no. X such that X is an element of the reals. This is written like this. It's like a C with a line through the middle of it. It's not a capital E. This real numbers sign is written with 2 bars right there. It is not written like a regular R. So on Google Classroom, you have some graphs on there, 2 images. We are going to do domain and set notation for those graphs. The first one we're going to do is one like you did in Algebra 1. Sorry, not Algebra 1, Algebra 2. We are adding the new part of the notation. We are starting off with our braces, or squiggly brackets if you like, our braces, to write in set notation. X such that X is an element of the reals. In this class, that is how it is always going to start. X such that X is an element of the reals. Domain is X values, so we're going to see how far left we go for our X values and then how far right we go for our X values. All the way to the left, we're right here, that's -1, 2, 3, 4, 5, 6, 7. So -7, less than X, less than 1, 2, 3 is how far right we go. And there's one more thing that we need to worry about. If we have an open circle or an arrow, that is less than. If we have a closed dot, that is less than or equal to. So this one has an open circle, that's just less than. This one has a closed dot, that is less than or equal to. And I need to close my braces. Notice that this is less than. This is never going to be greater than. It is always going to be less than. Over here on this next one, we'll see that we have a different type of function. You've never seen one like this before. This is called a piecewise function. More than one piece. A piecewise function has more than one piece. We're going to be talking about how to graph these in a little while, a couple of weeks. So we need to be able to write the domain for these. You have an example of how to write it on the notes that you were given. We are starting off the same way, X such that X is an element of the reals. That's how it's going to start off every time in this class for set notation. We're going to go from left to right. This point right here is the farthest left we go, that is -7, less than or equal to, because it's a closed dot. Remember, closed dot means that it actually hits that point, so it does equal that point, that X value. Less than or equal to X, less than, this is 2 to the left, -1, -2. That is an open circle. Open circle does not have the equal to bar. Now, this whole thing, both the line and the curve, is one function. So we need to put a comma for the second part of the function, and then we're just going to list off this second part. This is 1 to the right, less than or equal to, because it is a closed dot. X, less than, this is an arrow, so it does not have the equal to bar. And because it is an arrow going in the right-hand direction, that is infinity. I don't care that it's going up. I do not care that it is going up because I'm not worrying about range, I'm worrying about domain. Domain to the right, arrow forever, means that it's infinity. The reason it does not have the equal to bar is because you can never equal infinity. So, give you a chance to write that one down on the right if you'd like. Remember that you can pause to write anything down at any point. Two more examples of domain in set notation. I'm actually going to do the one on the right first. We need to talk about how to exclude a specific value. So right here we have this function, this curve right here and right here. This arrow shows that it goes up, this arrow shows that it goes down. This is a dotted line, shows that it never actually touches that dotted line. It is called an asymptote. That's a big topic in the second quarter. So what this is showing is that this graph is everything between this point, every x value between this point and this point, except for that asymptote. So we are going to exclude that x value. We're starting at set notation the same way. X such that x is an element of the reals, comma, our leftmost value, 1, 2, 3, 4, 5, 6, 7 to the left, -7, less than or equal to, because of the dot, closed dot, x. And when we need to exclude a single value in set notation, we are going to go all the way to the right and do this one, 1, 2, 3, 4, 5, 6, 7, less than or equal to 7. We're going to exclude that single x value by saying x is not equal to 1. That one value that we have. Remember, not equal to is written like that. Okay? Not like that. Okay? So x is not equal to 1. That's how we exclude a single value. Left-hand side. Set notation is always going to begin with x such that x is an element of the reals. It will always begin that way in this class. If you get into really high level math in college, it will change some. You might have a different symbol right here, but in this class it's always going to be x such that x is an element of the reals, comma. We're going from left to right. We've got this arrow on the left. Going toward the left is negative, and going forever is infinity, so negative infinity. Less than, you can never reach infinity. That's why right here I have that the arrow is less than, not less than or equal to. Less than x. And we're going to right here. That's 2 to the left, so less than or equal to -2. The equal to bar is because it's a closed dot, it actually hits it. Comma. We've got this second branch right here that starts at an x value of 0. Less than does not have the equal to bar because it's an open dot. X less than or equal to 1. This branch goes right to right there. Comma. 2 less than or equal to x less than. Okay, so this is just excluding a single dot, so we're going to deal with that in a second. We have an arrow going to the right. You know what? I'm going to erase this so it's a bit clearer. 2, we're going to skip over this. We'll deal with it in a second. Arrow going to the right is infinity, and in set notation, to exclude a single value, you're going to put x is not equal to whatever that is, which is 1, 2, 3, 4. Okay, so this is the full domain in set notation. Notice that I did break right here to a second piece because this is not connected. The values between 1 and 2 do not exist on this graph. So for instance, 1.5, 1.2, 1.23, etc. Those are not valid inputs for the domain on this. Okay, so that is domain and set notation. Email me or ask on Classroom if you have any questions. Till next time, be well, do good.